Alrighty, welcome. Today we're going to be talking about the coefficient of determination, r squared, who is the older sibling of Pearson's correlation coefficient, r. So r squared is literally equal to r squared. So if you take an r value and you square it, you should be getting r squared. However, as lots of you might know, squared numbers are always positive, which means that r, instead of being on a spectrum from 0 to 1, from negative 1 to 1, it is on a spectrum from 0 to 1. So since the r squared value is a little bit different than the r value, it does actually squish up our line for r squared. So as per previously, if you get an r squared of 1, that is perfect association. Then the strong category is actually all the way from 0.5 to 1, so it's actually quite large. The category for moderates between 0.25 and 0.5. Weak is then between 0.1 and 0.25. And then no association is just the small sliver between 0 and 0.1. Alright, but there's another way that we can actually use this r squared value. The other way we can do it is use it like a percentage. So we can use it to sort of explain. So I'll give you the sentence structure. So the change in y, our y variable, is r squared as a percentage, due to a change in x, being an explanatory variable. So the change in y is r squared percent due to a change in x. And so when I say r squared percent, if I say 0.5 is my r squared value, I wouldn't say 0.5%, I'd say 50%, because I would turn it from a decimal into a percent. So that's the basic idea. So let's have a look at it. So where causation is observed, we're going to finish the statement and write something about it. And where causation cannot be verified, we're going to discuss the reason. Okay, so distance traveled versus fuel consumed. Well, as you travel more distance, you're going to have consumed more fuel. So x and y, and it says the r value is 0.98, which means as the distance travels, increases, so too is the fuel consumed. So that's how we can read the first bit, which is just that this is n positive and strong. How can we put that into a sentence using r squared? Well, r squared is 96%. You can just times it by 100 to convert it to a percentage, and then we can just state. Using the sentence down the bottom, sentence pattern down the bottom. Alrighty, pretty good. Have a look at the next one. The number of hours of sunlight versus the temperature. R is equal to 0.5 and r squared is equal to 0.25. So with 0.5, we would say that's strong, moderate and positive. And with an r squared value of 0.25, we would think of that as like 25%, times it by 100. And now we can use the sentence. As the number of hours sunlight increases, does the temperature also increase? Well, yes, it does, but it's not the only cause. What are some of the other things that might affect temperature change? Well, I would like to think about if you lived in very close to the North Pole. If you live very close to the North Pole, it's actually very, very cold. But also, the sun doesn't set. Because you're so far high up on the Earth, you pretty much get almost 24 hours of sunlight. So for the most part, if you get more sunlight, that means that you're going to have warmer days, but it's not always the case. Hence, it is not strong positive, it's only moderate positive. Using the sentence, the change in the number of hours of the change in temperature is 25% due to a change in the number of hours of sunlight. Let's have a look at the last one. Level activity and weight gain. So we're getting a negative association, which means that as level activity goes up, weight gain goes down. That's what negative means. And 0.7 would also be moderate. For 9 would be 49% for our coefficient of determination, r squared. And now we can use the sentence. We can also just have a think about it. Do all of these causation make sense? As the distance traveled versus the fuel consumed. Well, as you drive more, you're going to use more fuel. That makes perfect sense. As the number of seconds versus temperature, we've already kind of had a quick think about that. It's not the only factor, but it certainly does contribute a little bit, and according to our thing, it contributes about 25% of that change. So then the last one is that level of activity is only about 49%. What are some of the other factors that might affect your weight gain? Well, some people who do a lot of activity are doing it so that they can actually gain weight in the form of muscle. Other people, in order to actually lose the weight, you're also then going to have to be changing your diet as well. So it's not the only factor. It's about 50% according to this statistic. So the change in weight gain is about 49%, is 49% due to a change in the level of activity. So just be mindful that just because we get a really strong variation, there's also other factors that could be at play. So there could be other explanatory variables, or there could even be a confounding or a compounding variable that is affecting both of our variables. So just keep that in mind. But that is the coefficient of determination. See you in the next one. Goodbye.